Hi, everyone. Thank you for having me. This is my first time in Malaysia. Just a little bit about me. He just said some of it, but I am from Atlanta, Georgia, in the United States. But I've been living in Myanmar for almost a year now, so quite close. I've been a developer at Cypress since its beginning as its first employee. I do a lot of things there. Currently, I'm developing on the main test runner and doing a lot of the support, writing a lot of the documentation, but I did used to do a lot of the original designs. This is my contact for Twitter. Twitter's probably the best way, my GitHub handle. Let me just review real quick what I'm going to talk about. We're going to have a quick overview of what browser automation is and the history of browser automation. Then I'll explain the core of WebDriver's architecture and approach to automating the browser. We'll go over some of the challenges with using WebDriver, and then finally dive into Cypress, how it's architected and different from WebDriver. So let's start with browser automation. Before we dive in, let's just quickly define what browser automation is and why you would want to automate a browser. Browser automation is simply, it enables you to programmatically control a browser. So you can use this to do things like test the behavior of your web application. Maybe you want to scrape content of live websites. You might want to automate manual entry tasks or automate taking screenshots of websites. But for the purpose of this talk, we're mostly going to be talking about testing website behavior to make sure it works how you've coded it to work. So if we look back at the history of browser automation technologies, the earliest approach that really took off was Selenium Remote Control, or Selenium RC. So this was in 2004. Jason Huggins was testing an internal application at ThoughtWorks, and he developed this JavaScript library that could drive interactions with a web browser. Then in 2006, Simon Stewart, an engineer at Google, started work on a product he called WebDriver. So they had been using Selenium, and they weren't really happy with how it was working out. Mainly, it was run in a sandbox JavaScript environment. So the WebDriver project began to try to solve the Selenium RC pain points. If you jump to 2008, 2009, the Selenium and WebDriver merged into the same project, and Selenium RC was basically retired. And then almost immediately after, these frameworks started popping up, these client libraries that allowed programmers to run Selenium WebDriver, but to run it in an API of their own design. So they extended it into other languages like Ruby and Python, and there are a lot of frameworks just in JavaScript alone. And then in 2014, the first commit to Cypress was made. So Cypress was made by Brian Mann. He's the creator, and he just wasn't happy using any of the tools to test web applications at the time. So he started from scratch to write this application to solve some of those challenges. So now in July 2019, the main Cypress project is open source. We have a whole team of people working with us, and we just got our Series A funding as well. So yeah, so for the next part of the talk, I'm not going to talk about Selenium RC at all since it's been retired, although it's pretty interesting. I'm just going to focus on the commonly used testing tools today, which are based off of WebDriver, the one from 2006. Right, so WebDriver. WebDriver provides a RESTful way to remotely instruct the behavior of web browsers. So WebDriver is part of the W3C recommendation as of last year. So if you imagine we have some test code, so take this as pseudocode. It just says expect an element to be visible on the page. Using the WebDriver protocol, we would communicate to any one of these browser drivers. So we have Chrome driver for if we want to communicate to Chrome, Gecko driver is for Firefox, etc. This is just a web server. So the W3 spec defines a set of HTTP requests that should be used to communicate to these drivers. The browser driver is then the party that is responsible to communicate to the browser. So it has freedom to decide how it implements this behavior completely. And then again, using the WebDriver protocol as it's specified, the browser driver is responsible to then send back an HTTP response. So this is basically, this is what the W3 spec defines for WebDriver, is this whole communication loop. If you wanted to include Selenium here, the Selenium server would sit between the protocol and your code. So it's just a proxy. The WebDriver protocol is organized into commands. So each HTTP request has a method and a URL that represents a single command. There's about 54 of them, so maybe you would want to get the title of your web application or switch to a frame, close the window. They're all single commands. And it's also available for extension if a browser had like a specific thing they wanted. Maybe Google Chrome wanted a command to emulate mobile emulation mode. They could add a custom command here. But however, the browser driver wants to implement how it handles it is completely up to them. So let's jump into like a real world example instead of jump out of the spec a little bit. If we wanted to walk through an actual testing example of WebDriver's implementation, so let's say we want to visit our web page and we want to make sure that there's an H1 header present. We want this automated. If we're using Selenium WebDriver, it would start with a post, this post session to get a session in the browser. The browser driver would then start up a new browser, so it would launch it, and then it would launch whichever one we had told it to. I didn't show the code that specifies that, but and then if it's successful, it should respond with a 200. So remember, from this point on, the browser driver is the one that's going to be in control of the actions in the browser. The next command would post to the URL we wanted to visit. The browser driver would then visit the page. It would wait for a load event to fire, and if the load event fired, it should respond with a 200. And the final command initializes a post to the element endpoint with the data we wanted for that H1 element. And this just results in a document.querySelectorAll. Yeah. So if our element is found, it should respond with a 200. And it'll respond with the serialized element. So it's just a string saying elements H1 found. So this is kind of a very ideal workflow. Everything worked, everything was found, no errors. But what happens if our document.querySelectorAll doesn't find our H1 on the page? Say maybe our loading view is still spinning, one of our XHR requests hasn't finished coming in, there's no content on the page yet. So if this happens, our browser driver should respond with a 404. And it has this error. It says unable to locate element, and our application is gone. This is how the majority of the failures look like when using a WebDriver, this kind of error response. So most JavaScript developers are not really familiar with using Selenium directly. Maybe if you've been doing testing, you've come across some of the frameworks. Maybe Protractor sounds familiar. There's a lot to choose from. Some of them have already come and gone. So these APIs, as much as they might improve the experience of writing the test, they're still susceptible to any of the flaws and challenges that WebDriver has because they are all built under the WebDriver protocol. So keep that in mind as we move on to these challenges. The first main pitfall of using the WebDriver is it wasn't as evident at the time when it was first created in 2006. So at that time, during WebDriver's initial creation, the web was mostly these multi-page applications, oftentimes a stateless web, where sites were static, not saving or changing any state on the client side. So since then, we've largely moved on to building single-page applications. It's a stateful web that delivers preserved state across these complex web applications. But the system that the core of WebDriver is built is a REST system, is stateless. So the theory behind these flaws is that a stateless system cannot deterministically communicate, model, or respond to a stateful system. This is kind of the definition of Flake when this system exists. To quickly demonstrate what I mean, we'll just go through an example in JavaScript. So in this example, we're using the set interval to just do a count. So imagine this is meant to represent some application code. Maybe you have in the browser where the count is being the state that you're maintaining in an application. So below this, we're just logging the value found in the count every 10 milliseconds. No, 100 milliseconds, yeah. So imagine this as the latency between a RESTful system like WebDriver would have. So it's hopping back and forth through those HTTP requests, trying to see what is the count now, what is the count now, right? So when you run this code to get a predictable result, to test that value, it ends up being impossible. Here's the output of the code we ran on the left. You can see that none of the values are predictably the same. So this is an example of a stateless system trying to observe the system from the outside. It's jumping in every 100 milliseconds or so, trying to see what is the count now, assert that it should be. So this is a pretty simplified example. A more realistic example would be, in your application, say having this count displayed in a DOM element and trying to observe that your counter is working as you coded it to be. Since WebDriver, it's designed to observe the outside of your application with a series of hops between each piece, you can't directly react or directly listen to these changes that have happened while that request is going to and from the browser. Another challenge of WebDriver is the debugging. It's not a very intuitive process. So when there are problems like we showed earlier where the element doesn't exist, the WebDriver responds with these HTTP error codes that can only be seen after all the tests have run. So you would then have to figure out what does this error message mean. At this point, our application is gone. The browser is closed. We just have this error message. This is usually the point where you start adding commands to save screenshots, all of your tests, and scanning through these static images afterwards to try and dive into the problem. And it's a bit like driving in the dark. As developers, we're used to debugging problems in the dev tools while our application is up and running, while we have access to the objects. So this debugging workflow can leave a lot of developers feeling frustrated. And then setting up an entire test suite in WebDriver is also a challenge. You need to install Selenium Server or one of the other JavaScript frameworks I showed earlier. You need to install the browser driver, the one that you want to use, so Chrome driver or Gecko driver. You'll want to install a test runner. So to structure your test, so this would be like Mocha or Jest. And you'll likely want an assertion library to use, so you can have this normalized structure on how to assert the things. So maybe this is chai or should. And if you want to do stubbing or mocking of functions or controlling the timers of your application, you'll want to install a library like Sign-On or to handle that. So this setup process is very tedious. It can sometimes take days, and it becomes a real blocker for getting teams to just quickly run things and test things out. So let's talk a little bit about Cypress Architecture, how it's different from WebDriver. The biggest difference between Cypress and WebDriver is that WebDriver has a RESTful command interface, right? So, but Cypress actually executes all the test code within the same context and run loop of as the browser. So that means Cypress can have access to everything in the browser, all the native objects, all the application code that you're testing. It doesn't serialize anything over the wire, so it has direct access to our application. Cypress also has a part where it can communicate to a node server so that it can do things like clearing cookies or clearing the cache, starting up the browser. Obviously, it has to do that because you can't implement everything directly from JavaScript in the browser. So how does Cypress solve this stateful versus stateless system? Since it runs inside the same browser context, Cypress can listen and respond to your application's events in real time. It can observe web traffic in real time, exactly what XHRs are sent and received. This is a little GIF of it running, but I will do a demo in a second. You can import code, application code directly into your tests to do things like component testing. You can call methods and access objects directly from the test you ran. Something else you can do that you can't do in WebDriver, you can listen and debug uncaught errors coming from your application code. So another thing Cypress addresses is the setup. It was a big focus of the project when we started. You can just npm install Cypress. It comes bundled with Mocha and Chai and Sign-On, so there's no extra installation necessary to write assertions or to spy and stub and mock. And then you just run Cypress open to open the test runner, which I'm going to go ahead and give a quick demo. Yeah, so we're going to test to do MVC, pretty simple application. Let's. I have the application code here. It's actually written in React, but they do have Angular examples because that's the point of To-Do MVC. It's written in many different languages. The To-Do MVC project actually uses Cypress to run tests across all of the different frameworks. So let's just get our server started. npm start. So you can see it's this application. I already had some things in here. It just keeps to-dos, like attend the conference. You can check off and delete things. It's boring. Yeah, so let's close this. And let's get Cypress up and running. So let's see how we will do that. Cypress is just a dependency like I showed before. This is our package JSON. It's just a developer dependency. We did npm install. I already did that so that you don't have to watch me install. Yeah, so all we have to do is run Cypress open. And Cypress will open a desktop application. And this desktop application, it shows all of the files that you have within the Cypress integration folder. It also allows you to choose different browsers. Right now, we only have Chrome and Electron support, but we're working on supporting more. So you can see it's just reading in these files here. So let's just create a new demo spec for today. Demo spec, and you can see Cypress already sees it, it's watching, so it knows we have this new file. I'm actually going to put in this reference at the top. So this is just a little shortcut to get types in your JavaScript. But you can set it up more in depth if you just add some tsconfig. It's just so we can have some types today for the demo. Right, so let's just write a simple test. It is true. Expect true to be true. This should pass. Let's click on our demo spec to get it running. Yeah, expect true to be true. It's green. Or we can expect it to be false. And it's already reloaded. It reloaded behind the scenes because it's watching our test files, so it's quite quick. So now it's red, it's failed. But this is a bit boring. It's just unit testing. Let's write something more interesting about our to-do app. So it adds a to-do, let's say. So we'll use our first Cypress command here. We'll use sci.visit. And you can see the TypeScript. We have types so that it can guide you through kind of how to write each command. So we just need to put the URL here, which is localhost. Which one is it? .888, I think. 8888. So if we save it, and run our test. Sci.visit. Is my server still running? Yeah. 888. Oh no. Oh, you know what this is? I'm visiting, yeah, HTTPS. I think someone called it out. It's not the correct site. Yay. So it visited our localhost site, and this is our application. It's our application as it would be in the browser. You can type in here. You can inspect it with the dev tools. Yeah, so we visited our application. We want to test adding a to-do, though. So what do we want to do? We want to type into here and press enter to add a new to-do. That's what we want to automate. So Cypress has this little selector playground that you can play with to get, we want this new to-do. So it suggests this site.get new to do, right? I can copy this command. So we get the new to do, and then we want to type into it. So what is the Cypress command for that? Is type. So what do we want to do? We're going to go to karaoke. And it automatically reruns, and you can see, it was a bit quick, but you can see it's typing. And if you want to also hover over it, you can go back in time. So you see it's loading here, we're getting our new to-do, we're typing. You can kind of see this before and after of each command. So, and let's hit enter. We have these special character sequences that you can do, so you can type enter. And we can see it's hit enter and it's added it to the line below. So we want to write a good test. We want to make sure that it's added to our new list. So let's get our to-do list. I already know what this one is. And get the li. And we'll get the first li. So we have a command to just get, this is just getting the first index of that, which is 0. And we want to make sure that it, oh, we need to find the label. There's the label. I'm trying to skip some steps here to save time. So it should contain this text that we type below. Go to karaoke. Yeah, and our test pass, the label contains the go to karaoke. What if it didn't pass? So Cypress reruns each command for a certain amount of timeout. So it's looking, because we know that there is some state involved in the application. This could change over time. So we look for a while to see if this label has the text yet. It didn't find it within our 4-second timeout. So this one failed. But we're just in a browser within Cypress. So we can also use our dev tools. So yeah, we can use the dev tools like usual. We can go in here and debug. Everything is here at the exact step that we have our test failing, which is what makes it so different. You don't have to go and sift through all these screenshots later. Yeah. So that's just a very quick demo. There's a lot more to Cypress. We're hiring a lot of positions, so please visit our website or talk to me. It's completely remote friendly. I live in Myanmar and our company is in the US, so very remote friendly. Thank you for having me.